the universe create itself? It's a question that has puzzled scientists, philosophers, and curious minds for centuries. Today, we dive deep into the possibilities of cosmic creation, discussing the origins of our universe and exploring whether it's possible for the universe to emerge out of nothing. And if it can, how long would such a process take? Join me on this fascinating journey as we unravel the mysteries of creation, time, and space. The most widely accepted explanation for the origin of the universe is the Big Bang Theory. According to this theory, our universe began roughly 13.8 billion years ago in a singularity, a point of infinite density and temperature. In an instant, this singularity expanded and cooled, forming galaxies, stars, and planets. But how did this singularity come into existence? Was it created by some external force, or could the universe have brought itself into being? This question challenges our understanding of physics and metaphysics, forcing us to rethink the concept of creation. Some theoretical physicists, like Stephen Hawking, have proposed the idea that the universe could potentially create itself. Using the principles of quantum mechanics, they suggest that the universe can arise from a state of quantum nothingness. In this realm, particles pop in and out of existence spontaneously. If quantum fluctuations can produce particles, then it's not inconceivable that an entire universe could emerge through this process. But this idea raises even more questions. Does this process follow a timeline? And what does nothing really mean in this context? One of the biggest hurdles to understanding a self-creating universe is the concept of time itself. Time as we know it began with the Big Bang. So if the universe created itself, it would have had to do so outside of time, in some timeless state. This is difficult to grasp because we are so used to thinking about events happening in chronological order. But what if creation isn't bound by time at all? This opens up the possibility that the universe didn't take any time to create itself. It simply was. Another intriguing idea is that the universe could be cyclical, meaning that it goes through phases of expansion and contraction. After expanding for billions of years, the universe might eventually contract back into a singularity, only to explode into existence once again in another Big Bang. This cycle could continue infinitely, with no need for an initial creation event. If this is the case, the universe doesn't need to create itself from nothing. It has always existed in one form or another. What happens at the end of time? If time eventually comes to a halt, could creation begin again? Some scientists speculate that as the universe continues to expand, it may reach a point where time becomes irrelevant. In such a scenario, new universes could emerge in parallel dimensions, born from the ashes of the old one. This could mean that creation is an ongoing process, happening across multiple timelines and dimensions. The idea of a self-creating universe, then, might not just be confined to our reality, but could be happening in many others. One of the more mind-bending theories about the universe's origin is the multiverse hypothesis. This suggests that our universe is just one of many potentially infinite universes, each with its own set of physical laws. In this context, our universe's creation may have been a random event within an infinite multiverse. If other universes exist, some could be undergoing their own creation processes, meaning that the concept of self-creation might be happening everywhere, all the time. Dark energy plays a crucial role in the current expansion of the universe. This mysterious force accounts for approximately 68% of the universe's total energy and is driving galaxies further apart at an accelerating rate. Some scientists speculate that dark energy could hold the key to the universe's eventual fate, whether it continues to expand indefinitely or collapses back into a singularity. If dark energy is an integral part of the cosmic cycle, it might even be involved in the creation process of future universes. Time as we experience it may not be as linear or straightforward as we think. Some theories suggest that time is merely a construct of human perception, and in reality, it might not exist at all. If time is an illusion, the question of how long it would take for the universe to create itself becomes irrelevant. Without time, there is no before or after in which the universe could be created. It just exists in a timeless state outside our comprehension. Quantum gravity, a theory still in development, seeks to reconcile general relativity with quantum mechanics. Understanding how gravity behaves on a quantum level could help explain how the universe came into existence. If quantum gravity allows for a universe to emerge from a quantum vacuum, we might finally have a framework for understanding self-creation. This theory could also offer insights into what nothingness truly is, and how something as vast as the universe can spring forth from it. Some physicists propose that black holes could be the seeds of new universes. When a star collapses into a black hole, its core becomes an infinitely dense singularity, much like the one that supposedly birthed our universe. Some speculate that inside black holes, the conditions might exist for entire new universes to form. If true, this would suggest that the process of creation is ongoing and happening within the universe itself, with every black hole potentially giving rise to a new cosmos. Entropy, the measure of disorder in a system, plays a significant role in the universe's eventual fate. Over time, entropy will continue to increase until the universe reaches a state of heat death, where all energy is uniformly distributed and no useful work can be done. But could this final state be the beginning of something new? Some theories suggest that once the universe reaches maximum entropy, it could reset, leading to a new Big Bang and the birth of another universe. The anthropic principle suggests that the universe appears to be fine-tuned for life because if it weren't, we wouldn't be here to observe it. This principle raises questions about the nature of creation. Did the universe create itself in such a way that it could eventually support life? Or is our universe one of many, and we just happen to exist in the one where conditions were right? If so, the self-creation of the universe could be part of a larger cosmic process aimed at generating life-supporting conditions. Symmetry is a key principle in physics, governing everything from the shapes of molecules to the large-scale structure of the universe. Some scientists propose that the universe's creation could have been driven by a quest for symmetry. In this view, the universe may have started from a state of perfect symmetry that was broken as it expanded. This breaking of symmetry could be what allowed matter, galaxies, and stars to form, giving rise to the universe we see today. The holographic universe theory posits that our three-dimensional reality is actually a projection of information stored on a two-dimensional surface at the edge of the universe. If this is true, the universe could essentially be a complex hologram that created itself. This theory could provide a new way to think about self-creation, as it suggests that the universe might not need to be built from the ground up, but rather projected from some underlying informational structure. Another fascinating idea is the simulation hypothesis, which suggests that our universe is a computer-generated simulation. If we are living in a simulation, the universe's creation might have been nothing more than the start of a highly advanced computer program. In this scenario, the question of whether the universe created itself becomes moot, as it would have been created by some external intelligence. However, this still opens up philosophical questions about the nature of reality and whether a simulated universe could be considered self-creating in some way. In quantum mechanics, virtual particles constantly pop in and out of existence, even in a vacuum. These particles are temporary and appear without any apparent cause. Some scientists believe that the entire universe could have originated as a kind of virtual particle, a fleeting fluctuation in the quantum vacuum that expanded into the vast cosmos we know today. If this is the case, the universe's creation might have been a random event, occurring without any external cause. Eternal inflation is a theory that suggests the rapid expansion of the universe never really stopped. Instead, different parts of the universe could continue to undergo inflation, creating new pocket universes along the way. This process could be eternal, with each pocket universe potentially developing into a fully fledged cosmos like our own. If this theory is true, the universe might be constantly creating itself, with no beginning or end, just an infinite chain of expanding universes. Some philosophers and physicists propose that the universe is a mathematical structure. If this is true, the universe could be self-creating in the sense that it emerges from the inherent properties of mathematics itself. According to this view, the laws of physics are simply expressions of deeper mathematical truths, and the universe exists because it must, given these underlying mathematical principles. In this sense, the universe's creation could be an inevitable consequence of the rules of mathematics. Despite our best efforts to understand the universe, there are still vast gaps in our knowledge. Some questions, like whether the universe can create itself, might never be fully answered. The limitations of human understanding mean that certain aspects of the cosmos might always remain a mystery. However, these unknowns also drive scientific inquiry and philosophical reflection, pushing us to explore deeper into the nature of existence. As science advances, we may one day discover definitive answers to questions about the universe's creation. Breakthroughs in quantum mechanics, cosmology, and theoretical physics could provide new insights into how the universe came to be and whether it is capable of creating itself. Until then, we are left to speculate, imagine, and explore the incredible possibilities that lie at the heart of our existence. Could consciousness play a role in the universe's self-creation? Some speculative theories suggest that the observer influences reality on a quantum level. According to the participatory universe concept proposed by physicist John Archibald Wheeler, the act of observation might help shape the universe's existence. This leads to the profound idea that consciousness and the universe are interconnected, with conscious beings possibly playing a part in the ongoing creation of reality. If this theory holds, then perhaps the universe and consciousness co-create each other in ways we have yet to fully understand. In everyday language, nothing means the absence of anything. But when physicists talk about the universe emerging from nothing, they're referring to a state that is far more complex than just empty space. Quantum nothingness isn't a simple void. It's a sea of fluctuating energy and potential. In this context, nothing might actually be the ground state from which everything, particles, forces, and even time can spontaneously emerge. Understanding what nothing really means could be the key to unraveling the mystery of how the universe created itself. One of the fundamental laws of physics is the conservation of energy, which states that energy cannot be created or destroyed, only transformed. So, if the universe created itself, where did the initial energy come from? Some scientists suggest that the total energy of the universe might actually be zero. In this view, the positive energy, in the form of matter and radiation, is perfectly balanced by the negative energy, in the form of gravity. If this is true, the universe could have emerged without violating the laws of energy conservation. Time appears to move in one direction from past to future, concept known as the arrow of time. But why does time flow this way? Some scientists propose that the arrow of time is linked to the universe's expansion. As the universe continues to grow, entropy increases, giving rise to the perception of time moving forward. If the universe could reverse its expansion, could time flow backward? And if time itself can change direction, how does that affect the concept of creation? These questions challenge our fundamental understanding of time and its role in the universe's existence. In both science and philosophy, there is a long-standing debate about the first cause, the initial event or force that set everything in motion. If the universe created itself, what was the cause of that creation? In religious and metaphysical traditions, this question is often answered with the idea of a divine creator. In scientific terms, however, the first cause could be a natural process, like quantum fluctuations. Yet, even if the universe emerged from quantum nothingness, we're left with the deeper question: what caused the quantum fluctuations in the first place? String theory offers a potential framework for understanding the universe's origins. According to string theory, the fundamental building blocks of reality are not particles, but tiny, vibrating strings. These strings exist in multiple dimensions and could give rise to the entire universe. In some versions of string theory, Our universe might have been born from the collision of higher dimensional brains, membranes. This collision could be the event that triggered the Big Bang and the creation of our universe. If true, string theory might offer insights into the deeper mechanics of self-creation. The observable universe is only a small fraction of the entire cosmos. Due to the speed of light and the universe's continuous expansion, there are regions of the universe we will never see. This means our understanding of the universe's creation is limited by what we can observe. There could be processes happening beyond our cosmic horizon that play a crucial role in how universes are born. Our limited perspective might be preventing us from seeing the full picture of how the universe came into existence. Another possibility is that the universe is eternal and has no beginning or end. This idea, known as the steady-state theory, was once a popular alternative to the Big Bang theory. Although it has fallen out of favor, the concept of an eternal universe still holds appeal for some scientists and philosophers. In an eternal universe, there would be no need for a creation event because the universe has always existed. If this is the case, the universe's self-creation might be a misunderstanding of its true nature. The universe's physical constants, like the speed of light and the force of gravity, seem fine-tuned for life. If any of these constants were even slightly different, life as we know it wouldn't exist. This apparent fine-tuning raises questions about whether the universe was designed in some way. Could the universe have created itself with the specific goal of producing life? Or is this fine-tuning just a coincidence, a natural outcome of the laws of physics? Science fiction has long been fascinated with the idea of the universe's creation. From Isaac Asimov's stories to modern films like Interstellar and The Matrix, writers and filmmakers have explored speculative ideas about how the universe came to be. These fictional accounts often reflect real scientific theories, like the multiverse or simulation hypothesis, but they also push the boundaries of imagination. Science fiction serves as a creative playground for exploring ideas about creation that might one day inspire real scientific discoveries. Cosmic inflation is the theory that the universe underwent a rapid expansion in the first moments after the Big Bang. This period of inflation could explain why the universe appears so uniform on large scales. Some scientists believe that inflation might not have been a one-time event. Instead, it could be happening constantly, creating new regions of space-time, potentially even new universes. If cosmic inflation is eternal, the universe could be in a constant state of self-creation, with new regions being born all the time. Does the universe have a purpose? While science tends to focus on how the universe works, philosophical and religious traditions often ask why the universe exists. If the universe created itself, was there a purpose behind its creation? Or is the universe an accidental byproduct of natural processes? This question touches on deep philosophical and metaphysical issues that science alone might never be able to answer. Some speculative theories suggest that the universe itself might be a kind of living organism. Just as cells divide and reproduce, could the universe create new universes in a similar way? This idea, while highly speculative, presents a fascinating way to think about the universe's self-creation. If the universe is alive in some sense, its creation could be part of an ongoing biological or cosmic process that we are only beginning to understand. In physics, symmetry breaking refers to a situation where a system that appears symmetric loses that symmetry. This concept is important in explaining how the early universe evolved. The universe may have started in a perfectly symmetric state, but as it expanded, this symmetry broke, leading to the formation of matter and the structure we see today. Symmetry breaking might be a crucial part of the universe's self-creation, as it allows complexity and structure to emerge from an initially simple state. As we continue to develop new technologies and methods for exploring the cosmos, our understanding of the universe's origins will only grow. Future discoveries in cosmology, quantum mechanics, and particle physics could provide new insights into the question of whether the universe can create itself. While we may never have all the answers, the quest to understand the universe's creation will continue to inspire generations of scientists and thinkers. If our universe is just one of many, how did it come to be? The multiverse theory suggests that multiple universes exist simultaneously, each with its own set of physical laws. In this framework, our universe might be one of countless others, all created through natural processes like cosmic inflation or quantum fluctuations. The idea that the universe created itself might only apply to this universe, while other universes could have entirely different origins. Gravitational waves, ripples in space-time caused by massive cosmic events, could provide new clues about the universe's creation. By studying these waves, scientists hope to learn more about the early moments of the universe, including the Big Bang. If we can detect gravitational waves from the moment of creation, we might uncover new evidence about how the universe came into existence and whether it created itself. Some scientists believe that information might be the fundamental building block of the universe. In this view, the universe is essentially a giant information processing system, and its creation was the result of information being organized in a particular way. If this is true, then the universe's creation might have been driven by the laws of information theory, with self-creation being a natural outcome of how information behaves on a fundamental level. In quantum field theory, the vacuum is not an empty void, but a state filled with fluctuating energy. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.